Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel tanmoyChem. Today's topic of discussion is one MCQ. The question is in front of you. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box. I believe you have done, so let's start. Now, look at question. What is the order of acidity? Here if you see, they are phenol derivatives. One is simple phenol, another is methyl substituted phenol. This is para substituted, this is meta, and this is ortho. What is the acidity? So whenever question given about acidity, you need to think one thing: what is the stability of conjugate base? So here look at what is conjugate base. Conjugate means if you remove the proton part, whatever negative charge or the anionic part is remaining, that is called conjugate base. And remember one thumb rule: higher the stability of conjugate base, I mean if this part is more stable, acidity will be more, means more amount of proton will be released. This is the thing. Now let's look at what is the structure of conjugate base from each of these structure. So if you look at, this is 2-methyl phenol, which also called as student ortho-cresol. This is the conjugate base. Here it is meta position methyl phenol or meta-cresol. This is the conjugate base. If you look at OH here, it is the para-cresol. So you can see the distance between the methyl group and O minus here. This is simple phenoxide. Now simple, what is the nature of this methyl group? This methyl group is, student, it shows the plus I effect and hyperconjugation. If I say plus I effect means donation of electron density through this sigma bond, carbon-carbon sigma bond donation. Now both are actually electron releasing group or electron donating group. We know one thing, that your conjugate base Cb is actually a negatively charged species. So what logic says, if your compound has some electron withdrawing group, this Cb will be more stable. If compound has electron donating group like methyl, Cb will be less stable. So from this logic we can say option 4, phenol, is maximum acidic. Now this is, we understand, pretty easy to conclude. Now second, which one will be the next? Now if you look at methyl group, it shows plus I effect and hyperconjugation, I agree, but where this thing occurs, it occurs with ortho and para. Let's show me this here. If I draw toluene here, so it will increase the electron density in this position to ortho position and para position. Now simple thing, if any phenoxide is attached to both ortho and para, the acidity will be expected to be less. Why? Because it is donating electron density, increasing electron density is this position. Consequently, what will happen? That phenoxide, if it is there in ortho or para position, I mean here or here, that will be less delocalized, I mean it is lesser stable. So so consequently you can say that, sir, this meta isomer is expected to be more stable among ortho, meta and para. So this is the second position. Agree? Now question, who will go to the third position? Now look at this methyl's position. So methyl shows both plus I and hyperconjugation. In ortho position, both plus I and hyperconjugation will be operating. But in case of para position, only hyperconjugation. So consequently, the electron richness is lesser here compared to here. So that's why third option is obviously here, this one, third. Who belongs to the fourth? Obviously one. Now from this we understand the relative comparison. So if I say any further proof, so you can see this pKa value. By the way, remember one thumb rule: if pKa is lesser, acidity is higher. So lesser the pKa value, higher the acidity. But by the, if you look at this value, will feel that, sir, very less. Yes, contribution is very less, but difference is there. Now this is the accurate value. If I take roughly, this is 10.3, this is 10.1, this is 10.2, and this is 10.0. So just very less difference, but still who is maximum? Obviously phenol. Second position meta 10.1. Third position para. Why? Because the destabilizing because of this methyl is lesser here. So that's why 10.2 and ortho case 10.3. So this is the order. Now a question you may think that are both plus I and hyperconjugation working simultaneously because of this acidity? Yes. So here both effect are working together, that's why we get such kind of order. So what is the order will be? Means acidity order 4 greater than 2 greater than 3 greater than 1. So 4 greater than 3 greater than 2, sorry 4 greater than 2 greater than 3 greater than 1. So this is the answer. Now we understand. Now if you do not know the exact thing, how can you find out the right answer at this situation in the exam hall? For that purpose, student, there is a strategy called process of elimination. Let's utilize here. So who should be maximum acidic? Since methyl is electron donating group, so compared to this, phenol will be maximum acidic. So option 4 will be top. So option A, B and D here, and automatically, sorry, option A, B and C will be, D will automatically go, it's gone. So now 3 options. Second position, obviously you need to understand that, sir, the methyl group and OH, their activity is in different way, because how this phenoxide is stabilized, if you look at this is O minus, it will donate its electron density, consequently this bond will open. So this is double bond O, negative charge here. Second canonical form, you can expect, sir, it can push and it will go. So negative charge will come to the para position with respect to the oxygen, double bond. So fine. Next canonical form, negative charge will come here, ortho position. I am not going. So ortho and para position, the negative charge. So here ortho is this, para is this. So methyl group will not interfere. So it will be the second position. So let's take option 2 is a second. So first 4, second option 2. First 4. So this is gone. B, first 4, second option 2. Okay. Now your option limited B versus C. Now what is the next? So who should be minimum acidic? So obviously 1. Why? Because methyl group is closer and ortho, OH. So least will be option 1 here. Option this. Or you can think it in a different way. Sir, maximum acidic, this option 4. Who is minimum acidic among all these 3? Obviously option 1. So 4 option 1, which is possible? Maximum 4, minimum option 1. So these 2, you can very easily come to the right answer. Next one, if you can get any one of these, for example 2, then this is the answer. I have shown you 3 different ways how can you come to the right answer. Apply any one of these, try to get the right answer as soon as possible, it will be done. So this is the end of this discussion. Thanks for watching. See you in the next video. Bye bye.